And we're back. Okay, so again, section 1.2 is titled data classification. Okay, so there's really two types of data that you could possibly have. And remember, data is really anything that you collect, right? Any piece of information that you collect. It could be heights, it could be temperatures, it could be favorite movies, it could be favorite colors, it could be whatever. And we can really talk about data in two different ways. We could say that data would be qualitative or data could be quantitative. Look at the root word of each to figure out what it is, right? So if I talk about data that is qualitative, okay, the root word there is quality, right? It has some sort of quality, okay? Not quantity, but quality. And that's where the root word of quantitative comes in as well. Oh, that's gonna be really annoying for you guys. So qualitative data consists of attributes, labels, non-numerical entries. Right? Qualitative has a quality, it has some sort of quality. So that would be like, okay, what's the month of your birth? Right? What is your favorite color? What is your favorite movie? Do you respond yes or no to a certain question? That's qualitative data. Does not have any sort of numerical value. Right? You can think about it in terms of like labeling it in a numerical way. Like you can turn qualitative data into quantitative data by saying like, okay, if it's a yes/no response, you could make 1 yes and 0 no. You could make it like just a 1 or a 0 type thing, and that turns qualitative into quantitative. But quantitative data is just basically numerical data. Numerical data consists of numerical measurements or counts. So we can define things to be qualitative or quantitative. And there can be a little mix of both. You can turn qualitative into quantitative, you turn quantitative into qualitative. It just kind of depends. The table shows sports-related head injuries treated in the U.S. Emergency rooms during a recent 5-year span of several sports. What set of data is qualitative? If I ask you, what is the set of data that is qualitative data in this case? The sports, the type of the sport, right? The type of sport. Okay, we have, 1, 2, 3, 4, 5, 6, 7, 8, 9 entries in that list, right? So we have 9 entries in that qualitative list. So which data are quantitative? The number of head injuries, right? Number of head injuries. Ooh, sorry for the very poor handwriting there. Number of head injuries, right? Numerical values are represented by quantitative data. Remember, think of the root word quantity. Quality data, qualitative data, that's the naming type of thing. Right? Okay. Now, what we're going to, oh man, this is going to be a start today. We have different levels and different kind of, you can call it classifications of data. We have these two branches where things can be qualitative or quantitative, right? But then there's different levels of measurement. Like, for example, data at the nominal level of measurement. It's qualitative only. Okay? There's different ways to talk about data, different ways to classify data. So if you classify a set of data as nominal, it is only qualitative. Data at this level are categorized using names, labels, or qualities. No mathematical computations could possibly be made at this level. So if you're saying, give me your favorite movie, that is a nominal level. That is a nominal level. If I just say, think about the root word of nominal, name alone, right? Only giving me a name of something. Like who's your best friend? Give me a name. Give me something. Give me just. No, I can't rank them. Ranking turns into something different, right? But when I just say, okay, give me the month you were born, right? That is a nominal level of measurement. Data at this level can be categorized using names, labels, qualities, but no mathematical computations would make sense. Okay. Now, if I move onward with that, if I can go beyond that and say, well, this data is not nominal, but ordinal. Root word there, order. Right? Data at the ordinal level of measurement are qualitative or quantitative. I could have quantitative or qualitative data. The sticking point here is that data at this level can be arranged in order, but differences between the data entries are not meaningful. So here's what I mean by that. If I said, okay, we're going to take a survey of favorite classes, right? And I was going to give 5 classes, and I was going to study all the students at Lake High School, and we're going to say, okay, give me put your favorite classes in order. So math would get a certain amount of votes, and English would get a certain amount of votes, and then in the end, I could rank them. I could say, well, math got the most amount of votes, so they're at the top of the list, and then English, and then social studies, whatever it may be. Right? That is the ordinal level of measurement. Okay, that is the ordinal level of measurement, because I can put them in order. Order is meaningful in that case, because I can say, well, 40 students, 400 students said math, but only 300 said English, right? I can put them in order. Order is meaningful in that case. Is the data qualitative or quantitative? Well, the data was still qualitative, right? Because I was asking you what, not a non-numerical response, right? I'm really just asking you what subject, right? So it's not numerical. So I could do qualitative data in that case. I could also do quantitative. Yeah, that makes sense too. Data at this level can be arranged in order, but differences between the data entries are not meaningful. So in that case, I know, I'm not saying, I'm trying to think of what that basically means. Like, think about it as like English minus math. That doesn't mean anything, right? The differences in there, the subtraction of the two, differences meaning subtraction, between the data entries are not really meaningful. I struggle to say, I think kind of in my example where I said I was giving you actual values of like, okay, 400 people said math, 300 people said English. The differences between the two would kind of matter. So that's where, again, it gets a little fuzzy from time to time. You kind of weed through some things. But take, for example, here, determine whether the data are nominal or ordinal. Nominal or ordinal. So I have 2 tables here. The first one that you see on the left side, top 5 U.S. occupations with the most job growth projected in 2024. Personal care aides, registered nurses, home health aides, combined food preparation and serving workers, including fast food, retail salespersons. Okay. Is that ordinal or nominal? Ordinal. Top 5. Did I rank them? Yes, I put them in order, right? So that's an ordinal level, right? This is an ordinal level. Okay. Movie genres. Nominal, right? I'm not asking, top 5 movies. No. That would be ordinal. I'm not ranking them at all, right? This is just nominal. Nominal data. Nominal data is just like the collection, right? Order doesn't matter. Order doesn't mean anything. If you rank them, well, then that's different. That turns nominal into ordinal. Okay. There are other levels as well. We've got the interval level. So moving beyond that, getting more mathematical to it. Data at the interval level of measurement are quantitative. So now qualitative has gone away. You should never have any qualitative data in the interval level of measurement. It's only strictly quantitative. The data can be ordered, and you can calculate meaningful differences between the data entries. The interval level is where it shifts, where I say, okay, it's no longer qualitative. Just ranking something in words doesn't mean anything anymore. Okay, I want to go beyond that, and I want to say, okay, how much more is something than the other, right? So if I look at like temperatures, oh, I should really look ahead and look at my examples before I get beyond it. Oh, I don't give examples for this. Okay. So if I think about temperatures, temperatures is a good level, is a good interval level, right? It's a good interval level because I can tell the difference from one day to the next, right? There's meaning to the difference, okay? There's meaning to the difference between one piece of data and the next. Like if it's 70 degrees the first day and then it's 30 degrees the next day, I can tell something based on that. There is difference between the two. The data can be ordered and you can calculate meaningful differences between the data entries. It means something when you calculate the difference between the two. At the interval level, a zero entry simply represents a position on a scale. And that, I think temperature is the best example for this because, zero is not necessarily zero of something on temperature, right? It's 0 degrees, but can I go below zero? Yeah, it's just like it's just a scale, right? It's just a scale. It's just representing temperature, right? It's not representing that there is zero of that thing, right? Zero is just an entry. It's not an inherent zero, but it's just an entry. It's just a location on that, right? I think like a number line as well, right? If you're just representing things in terms of a number line, I could go below zero, I could go above zero, and that still is allowed. It's just a position on a scale. So at the interval level, a zero is just a position. It's not necessarily representing zero of that thing. It's just a position. And again, the best way to describe that is temperature. Zero, think about it in terms of like, okay, well, Fahrenheit to Celsius, right? Does 0 Fahrenheit, that calculates to something in Celsius, right? Think about 32 degrees in Fahrenheit. What's that in Celsius? 0, right? So 0 is really just a position on a scale, whether you're talking about Celsius or Fahrenheit, right? So it just kind of depends, is 0 just a position? If it is just a position in whatever data you're talking about, well, then you would categorize that as interval level. So what if 0 actually means something? What if 0 actually means something? Data at the ratio level of measurement are similar to data at the interval level with the added property that a 0 entry is an inherent 0. When 0 means something. I think it did steal my example. Oh no. Okay, so this is our last level of measurement. Data at the ratio level of measurement are similar to data at the interval level with the added property that a 0 entry is an inherent 0. A 0 actually means 0. 0 actually means none of that thing. Another key, where it gets its name, another key aspect of the ratio level is that a ratio of two data values, a ratio of two entries, has meaning. A ratio of two data entries has meaning. So one data value can be expressed as a multiple of another. Okay. So if I say, I'm going to roll a dice 100 times, and I get, 21s, 32s. I can say, therefore, I had more ones than twos. Okay, that would be at the interval level. I had 10 more ones than twos. However, now I can say, well, I had 1.5 times as many twos than I did as ones, right? That makes sense in that respect. So that's where it changes from interval into ratio level. It's meaningful to say I had 1.5 as many times twos as I had ones. Right? Calculating a ratio between the data values has meaning, has sense. It makes sense. You can do something with that data. Okay, and that's where it changes from interval to ratio. As long as one data set can be expressed as the multiple of the other. All right. So let's take a look here. Determine whether the data are interval or ratio. Determine whether the data are interval or ratio level. Okay, on the left side here, I've got the New York Yankees World Series victories in years. On the right side, I've got the 2016 American League home run totals by team. Okay, one of them is interval and one of them is ratio. Let's go with the easier of the two. Which one's ratio? The second one, right? This one's ratio. Why? Because, well, I can have 0 home runs, right? Can I go into the negatives? That doesn't make sense. Right? I can have 0 home runs. I can have 0 amount of something in that case. And I can therefore say, well, if I want to compare LA to New York, or if I want to compare, who's got the high here, Baltimore? How is that possible? Who would have been on the team? Baltimore to, who's got the low? Seattle? Okay. Oh, no. Kansas City? Yeah. So if I could compare them, and I could make a ratio of them. I could make a ratio of Baltimore to Kansas City, and that makes sense in this case, right? At least in the home run totals. I could say 253 to 147 and calculate that. I have, half as many or 2/3 as many, and that makes sense, and that means something in this case, right? So that means this must be interval. And remember, the only difference is that interval does not really have an inherent 0. Think about time. Think about time. Is 0 actually representing 0 of something? Well, 0 years, I get that. But in terms of a sliding scale, could I go below that? I mean, yeah, it's kind of like temperature in that respect, right? Time is all relative to when you're talking about beginning and end. So in this case, the Yankees World Series victories, well, I can say that that's just an interval level. I can find meaningful differences between the data, right? I can say that, well, between it had been 9 years since 2009 to 2000. It makes sense to find a meaningful difference between the two. But a ratio of those years, well, that doesn't really help us in any way, right? We can't really conclude anything in that way, right? Now, if I switch that, see, and this is where it can get a little tricky and a little dicey. If I turn that data, if I turn the years into differences between, like differences of years between wins, right? And I say 4, 1, 4, 4, 1, 1. Well, actually, that would be 0 years in between. But you get the idea. If I was calculating years in between, that changes it from interval into ratio, right? Now that's a little bit more of a meaningful 0, because 0 actually means amount of years in between, right? So it means something when I change that from interval to ratio, meaning that 0 actually means something. And I can calculate ratios in between. I can say, well, it had been a longer time from one to the other, because I can say, well, how much longer? I can say 2.5 times as long in between one win to the next, right? And that those ratios do make sense. But when I take the data as specific years, well, that's just interval, right? So you can change data. You can take the same data and turn it from interval to ratio. That is possible, depending upon how you look at it. The issue is, you probably can't change nominal into ordinal. Well, no, that's not true. You probably can change nominal into ordinal if you change the question and say, like, okay, what are your favorite, right? Rank them. That takes nominal into ordinal. But you can't really take ordinal into interval, right? There are some that you can flow between, but there's some that you can't. Okay, you can't really take ordinal into interval. It doesn't really make sense to do that. Or at least I can't think of an example where it would make sense to take ordinal into interval. Now, the book does this, and I thought this was a really good diagram to talk about. Talks about the 4 different types of levels of measurement and the things that you can do with them, right? And you got to think of it like an umbrella. Okay, you got to think of it like an umbrella. A ratio, the ratio level, I can put nominal into categories, right? I can put nominal into categories. Can I arrange nominal? No. I can't subtract. I can't determine multiples of another. I can't make a ratio out of nominal level. Okay? Now, can I put data into categories with an ordinal? Yeah. I can put data into categories. Can I arrange it? Yeah. Can I subtract values? No. That's where the ordinal level stops. And I can't determine values of one multiple to the next. Right? Now, interval level. Could I put into categories still if I wanted to? Yeah. Right? I could put it into categories. I could take this data and I could say, okay, how many in the 1920s? How many in the 1930s, 40s? I could put it into categories by decade if I wanted to. Yeah, I could put it into categories. Can I arrange that in order? Of course I can. I did right there. Right? Time-wise, chronologically. Can I subtract those values? Yeah, that's what makes it interval. I can find the years in between if I wanted to, and that would make sense. But then I stop and I say, well, I can't find multiples of one another then. Right? If I change the data, look at amount of years in between, yeah, I could. We talked about that. But it wouldn't really make sense to use this data and say, okay, 1958 divided by 1950. It doesn't really do anything for me. It doesn't really tell me anything. Ratio level. Can I put it into categories? Yeah. Can I arrange it? Yeah. Think about this level. Could I say, okay, teams that had over 150, teams that had over 200 home runs? Yeah, I could put it in categories like that. I could even say by division too, right? If I really wanted to, I could say a lot of different things. I could put them into categories if I wanted to. That's basically what I'm saying there. Could I put them in order? Of course I could put them in order if I really wanted to. I could order them from least to greatest, right? I can put them in order. Can I subtract the values? Of course I can. This still makes sense and means something that if I subtract the values, if I take the difference between Baltimore and Boston, I can say, yeah, one's got about 45 more home runs than the other. And that makes sense. It means something. So I still can find the difference between the two. But now I can take that one step further and say, well, a ratio of 2 quantities means something, right? A ratio of 2 quantities actually means something, and I can tell something from that, okay? So do you see how this works here? The properties of the nominal level are kind of just stuck with putting it into categories. But when you drop down to a ratio level, you can do a lot more with the ratio level, right? And that's why we're going to be focused mostly down here through our data, okay? It doesn't mean we're never going to have a set of data that's only interval. And it doesn't mean we're never going to have a set of data that's only ordinal. I'm just saying that you can do more with ratio sets of data classified as ratio level, than you can with nominal level. Right? Nominal level is very basic, not even putting anything in order, just compiling a list of things. Like, what classes do you take? Right? That's the nominal level. Well, then if I said, okay, well, what periods do you take those classes? Am I putting them in order? Yeah, I'm putting them in order. At that point, I changed from the nominal level into the ordinal level, right? Can I change that data into interval? I don't think so. I mean, maybe if I assign them by period, I don't think so. I don't think that works in that respect, right? So I can change the level. But again, ratio levels are going to be the ones that we're going to talk about the most because we can do more with it. I can take a ratio set of data and I can put it into categories. We do that all the time with frequency tables. I say, okay, how many times do people respond in this way? In a certain interval. How many times do people respond in this way in a certain interval? Yeah. If I think about like how much time you spend sleeping, right? People that say 0 to 5 hours, people that say 5 to 10 hours. Would anybody say 10 to 15 hours now? I think I should have made my intervals a little different. But I can take that and I can say, well, different categories mean different things, right? And I can arrange them. I can put them in order. I can subtract the values, and it makes sense. Right? This many more people said 0 to 5 than this many more people said 5 to 10, right? And I can use that data to determine multiples of one another as well if I really wanted to. Okay. All right, so that's the end of section 1-2. I don't mind if you get going on your homework. I know 6 questions for homework. Oh my gosh. Yeah, you're going to be able to get that done in 20 minutes. No problem. Oh, forgot my video.